I'll be speaking through really the principles and procedures behind ASCE 41. And also, I gave a presentation similar for this venue about, I guess, 6 months ago now or so. And since then, this one's been updated to get in a little bit more to some of the updates in ASCE 4117, which will be adopted by the has been adopted by the IEBC, but also for those in California, and I'd imagine similar elsewhere, would be officially enforced starting at the beginning of this next year. I did put my email down there, by the way, if anybody has questions. We will have a couple breaks and time for questions along the way, but if we don't get to any, please feel free to shoot me an email at my email there. All right, let's jump into it. So first of all, why an existing building standard? We'll kind of talk through the reasoning there and kind of explain some of the differences between existing and new buildings. That'll be the first portion of the webinar. We'll then take a break and we'll come back and we'll dig further into, the ASCE 41 process, the philosophy, and then how you actually apply that to real buildings. And then we'll try and dig in a little bit into the ASCE 4117 updates. And as we're going through, I might touch on some of the things that are in the works. The next cycle for ASCE 41, which will be published in 2023, so it's a bit away from us, but it has kicked off that cycle. And even though ASCE 41 is a little further out, there are the concrete technical provisions and steel provisions have their own standards that will actually be coming out in the meantime. So I'll touch on those a little bit as well, so people can kind of know where to find updates and I guess when to expect those. So firstly, why an existing building standard? A lot of people are very familiar with ASCE 7. ASCE 7 is what we traditionally think about for getting our seismic designs to seismic loads or demands to buildings. And for a long time, there's been, this philosophy that you can either just use ASCE 7 directly, or maybe there's some relaxation, maybe a 75% factor on ASCE 7 loads, and you can effectively use that same design standard for existing buildings. However, there are quite a few differences between new design and existing building upgrade or even evaluation. We'll get into some of these in more depth, but it's important to realize that you really don't have a blank slate when you're dealing with an existing building. You don't get to decide in your existing building where ductility capacity is or where the ductility demands may be necessarily. The original designer may not have thought of those things. Certainly there's not the same level of construction quality control, if at all, and we'll talk through a little bit more. And another big difference is the target performance is actually dictated by either policy or maybe the existing building owner, and it kind of gives you a menu of options, a la carte if you will, on what you want your building performance to be under a given seismic event. So that's quite a bit different than ASCE 7, which is really just a minimum safety standard for seismic design. You have to meet the minimum, and that's about all you get. Nothing more, nothing less, other than maybe risk category considerations. But we'll talk through those. All right. So going back, actually, ASCE 41 is the standard that people are starting to get used to thinking about for existing buildings. But in reality, this concept of evaluating or looking at existing buildings differently than separately from new buildings or new design, this concept has been around for quite a bit of time. So going back to the mid-1980s, this ATC 14 document came out, and basically there was this concept built into it that you could have a 25% reduction to your new code UBC forces. This is kind of the genesis of this, at least in the US, where that 75% came in. And this trend has continued throughout for evaluation, basically in some fashion, even currently in the codes today. Fast forwarding a little bit to the mid-1990s, this Vision 2000 came out from SEOC, and there's this concept that was talked a lot about marrying a particular seismic hazard or a probability of a certain seismic event with a particular performance level. So kind of recognizing that people may be willing to accept a lot of damage as long as it was safe, the building was safe to maybe get out of it in a very large event. But if it's a smaller event, it may not be acceptable for the public especially to have a small event and then have a ton of damage.